Yeah.
Just
Okay, here we go. So a review. Okay, the slope-intercept form of a line. Somebody raise your hand and tell me what's the slope-intercept form. What's the slope-intercept form, Audrey? Y equals mx plus b. What is m in this case? M represents the slope. Okay, m is the slope. B is the y-intercept. Y-intercept. Okay, when we look at the y-intercept, you write it as 0, comma, b. Okay, whatever number b is. All right, it says write the equation of a line that has a slope of 1/2 and passes through the point 0, 4. 0, 4, that is a special point. What point is 0, 4? Got it? That's the y-intercept. Okay, so that means b equals 4. What does m equal? 1/2. Can we write a slope-intercept form equation? Yes. Y equals 1/2 x plus. All right, write a linear equation relating x to y. Can you locate the y-intercept? Where's the y-intercept? Where's the y-intercept, Jeremiah? 0, 20, right there. That would be like 0, comma, 20. So that means b is 20. We need to find m. Okay? Now, there's a couple of different ways you can do this. You can take 2 points and find it, or you can just use the table. If we go from 0 to 3, what happens? Add 3. Does the same thing happen from 3 to 6? Yes, okay. So that means that our slope is 3 over, I'm sorry, changing y. Changing y over changes.
That's because that could be the bottom numbers.
Sorry, I forgot. Cross that out.
Okay.
I realized when I looked at their notes, I didn't make it. I looked at the notes. Yeah, it's okay. All right, so 20 to 8. What happens to go from 20 to 8? Minus 12. Okay, same thing here. Minus 12. So our change in y is negative 12. Now you have to make sure you put that fraction right. It's the change in y over the change in x. Okay, remember when we talked about those, the funky looking notation? The triangle y, triangle x? Okay, that's change in y, change in x. All right, what's 12 divided by 3? All right, so we have our slope and we have our y-intercept. Now we can write our equation. Y equals negative 4x plus 20. Questions so far? Are you tracking with me? All right, so example 1. It says we are using linear equations to solve real-world problems. That's what this unit 5 is about, okay? We have to decode the word problem to find the slope and the y-intercept. So within the word problem, there's the slope and y-intercept. We just have to find it, okay? It says a balloon is released from the top of a building. The graph shows the height of the balloon over time. What is the initial height? 0.5. That's wrong. Let me tell you why.
What the heck?
Look at the units. 1,000 feet. So if it's at 0.5, how many feet is that? 500. You tracking?
Yes.
Okay. So if this is going by, if this is thousands of feet, half of that is 500. Okay. I'm sorry.
We can't see it.
Oh, let's see.
That's why I was so confused.
Okay, just label that. Okay, it goes in thousands. That's okay. Sorry about that. Okay, so it goes in thousands. So our change in y is what? 500. Okay, and then our x goes by what? Tens. Oops. Gotta erase that. I'm sorry. I'm sorry. That was the y-intercept. That was the y-intercept. I got a little ahead of myself. Yeah, we were finding the y-intercept. We weren't finding slope. Sorry. All right, let's go to slope now. If we had picked 2 points, let's say we pick this point and we pick this point. Okay, we can just do rise over run. If I go from 0.5 to 1.5, how many feet is that? 1,000. Because every unit is 500 because it's half. Yes? Okay. So this is 1,000, sorry, over, what's my unit here? 10. Okay. So our slope is 1,000 over 10, which is 100. Not all graphs will be this hard to kind of figure out. Okay, not all. But sometimes you'll have to look at the units. Okay, so our equation, y equals 100x plus 500. All right, so what does the y-intercept of 500 mean when it comes to this problem? Okay, so the balloon starts right at time 0. So this is the initial height of the balloon, or the starting height of the balloon. The starting height of the balloon. Interpret the slope in the context. So what does the slope of 100 mean, Gavin? Yeah. Yes. So it's gaining 100 what? 100 feet per second. Because it's technically 100 over 1. Okay? So it's gaining 100 feet per second. Okay, now let me ask you a question. Could technically the balloon keep going on forever? Like keep getting higher? Yes. So we're going to put an arrow at the end of our line. Yeah. When we start with domain, domain is x. What's our first x value? No, 0. I heard 0. Okay, 0. Where does it stop? To infinity, right? Because this keeps going and going and going and going and going. We don't know a time, right? Think time, x. We don't know when that time is going to end, right? That balloon's going to keep going on forever. So it'll be 0 to infinity. All right, what questions do we have? Okay, so let's talk real quick. Okay, let's talk real quick. We are going to be using linear models. Always, always. When we focus on y equals mx plus b. Okay, every single time. So this is kind of telling you that. Okay, the starting value. So what I want you to really realize is this y-intercept and starting value. That is very common. When I ask you what the context is in the specific word problem, it's usually going to be starting value for the y-intercept. Okay, that's very common. All right, here we go. Example 2. Okay, y-intercept is always easy to pick out. What's the y-intercept here? 20. Okay, now slope is a little bit more difficult. To find slope, I would use 2 points on my line. What's my rise? 10 and over 1. So 10 over 1 is a slope of 10. Right, equation of the line. Y equals 10x plus 20. Okay, now, our last problem did not have words to help us. This problem does. So let's go back to the directions. The graph for a stable that charges a $20 flat fee plus $10 per hour. $10 per hour is going to happen again and again and again. Can you agree with that? Okay, so if something is going to be reoccurring, meaning it's going to happen again and again and again, that's always going to be your slope. Everybody say slope. Slope. Okay, x if it's happening one time, everybody say one time, it's always going to be your y-intercept. You tracking with me on that? Okay, so here's how I remember that. If it happens once, I plot that point to start, I'm done. Okay, that's the y-intercept. Then the thing that keeps changing is going to be that slope. Okay, does that help a little bit? All right, so interpret the y-intercept in context. You can always use the words to help you. Somebody raise your hand and tell me, what does the 20 mean? What does the 20 mean? Yeah, right? She got charged a flat fee for using the stable, okay? So this is a $20 flat fee. Raise your hand and tell me, what does the slope mean? What's the slope mean?
You get $10 every hour.
So you don't get $10 every hour. We're talking about a state. Yeah, you're paying $10 per hour for horseback riding. Okay. So we'll say 10 per hour for yeah, that works. For riding. So if you were to sign up with a specific stable, you would pay them $20 initially, and then every time you come to ride, you would pay $10. Huh? Too much? Okay, let's talk domain. Okay, I don't know if you can see it, but there should be an arrow there. Why does it make sense that there's an arrow on this graph? Why does it make sense there's an arrow? Kyle, I love it. You can ride forever. Right? Maybe the stable will shut down, but there's no point where you will stop riding. Okay? So, domain. What's our starting hours, amount of hours? 0, right? You could ride for 0 hours. So we're going to say 0 to what? Infinity, because we don't know when you're going to stop riding. All right, let's talk about it. How will the graph change if the stable charges a flat fee of $45 and 30 per hour? Well, pricey. What's going to change? The slope and the y-intercept, right? What's my new slope?
30.
$30 per hour. That's going to change. That can happen again. Whenever you see flat fee of 45, flat fee means one time. What did I say was always one time? Yes. So would this be a steeper line? It would be a steeper line. Right? They would start here at 30. Okay, and it would go, oh golly, 45. I don't even know if I could graph that. It would be a little bit off the graph, wouldn't it? It's gonna be like, yeah, it's gonna be like straight up. Okay. All right, let's keep moving. Example 3, the cost of a school banquet is $95 plus $15 for each person that attends. Which one is happening over and over and over again? 15, because you don't know how many people, right? So it's 15 per people. And then that $95 is just a one-time cost. So our equation is y equals 15x plus 95. Now, interpret that y-intercept. Who can tell me what the y-intercept means? What's the y-intercept mean? I'm gonna set this. I'm not setting that by electronics.
You want it over here?
Oh, you're like 16 and so I forgot.
Skipping over that every time I put it down. It's just
Okay, let's keep moving. All right, y-intercept. Tell me about the y-intercept. Okay, so there's a $95 initial charge. Okay, or initial fee, or you can say flat fee. You're going to get charged $95 no matter what. Then the slope. Tell me, what does the slope mean?
Each person attending.
Yeah, so each person attending what? They're going to get charged $15 for each person. Okay, each person costs $15 to attend. So $15 to attend is that slope. All right, is that all there was for that one?
No.
Oh, we're on the same one. Okay, so state the domain. Ooh, interesting. Okay, so let's think about it. What does X represent? X is what? The number of people. Because we're taking $15 and multiplying it by the number of people. Okay, so when we think domain, okay, what is the least amount of people that can attend? 0. You will never have a negative number of people attend. Agreed? Okay, so 0. Do we have a cap on how many people can come? No, so it's going to be infinity. Yes, very good. Going to be infinity. Yes. Okay, what is the cost for 77 people? How are we going to find that? Plug in 77 for what? Yes. So X equals 77. So we're going to plug that in to our equation. All right, plug and chug. Put it in your calculator. Plug and chug. What do you get?
1250.
Do we agree with 1250? No.
I got 2,000.
Try it again. Did anybody else get 1250?
Yeah, I got 12.
Okay, should be 1250. Okay, so is this people? No, we're saying Y is 1250. What's Y? The cost. So it's going to cost $1,250 for 77 people to attend the big one. Pretty pricey. All right, G is a little bit different. How many people? People is what? X. So how many X? That means we're solving for X, right? So how many people are attending the banquet if there's a cost of $245? What's this going to look like when we said that? Yes, you set $245 equal to your equation. All right, make sure we're focused here. Okay, stay with me. All right, now what are we trying to do? We're trying to solve for X. Okay, so go ahead and solve for X. I know that you can do that. Okay, go ahead and get X by itself. All right, so that means $10. 10 people can attend. Okay, that would be a pretty small banquet, but still.
Oh, wow, did I ask you?
All right, example 4. Okay, it says Maria charges $15 for every 2 hours. Okay, so let's just hold up a second. $15 every 2 hours. How much is that for 1 hour? 15 divided by 2, right? That would be $7.50 per hour. You tracking with me on that? Yeah. Okay. So, if it's 4 hours, how much would it be?
30.
6? Yep. 8? 60? 75, and 90.
Now we're gonna act like
She needs to charge more. Right? Can you imagine working for 12 hours and you make $90?
I mean,
That
200
stinks.
I mean, out for 200 per hour.
200 per hour. Okay, let's do the equation of the line. So tell me, okay, what do you think is the slope of this line? What is constantly changing? What's getting added again and again? What was it? 15. I don't really like 15. Why don't I like 15? That's every 2 hours. What's per hour? 750. Okay, or 7.5. So that's a little tricky. You have to think per hour. All right, now, our B. What would a y-intercept in this case be? Okay, so it's when x is 0, so that would mean 0 money for her. So what would be the y-intercept if she has 0 money? 0 hours, right? She would work 0 hours. Is that possible?
Yeah.
Absolutely.
Dang, that means I wouldn't even have to go into work and I still
No. You mean if she did get paid for not?
Yeah.
Yeah. But in this case, no, right? She doesn't work, she doesn't make money, which is pretty common. All right, so and we kind of just talked about that, right? 0 hours. She didn't work. What about the slope? What do we say for the slope? Yep. Maria makes $7.50 per hour.
What?
Okay, let's go ahead and graph this guy. So I would just graph the points that you have here. We know that 0, 0 is a point. 2, 15 is a point. These go by tens, by the way, so you have to be careful.
Wait, 2, what's 4? 4, 30? That's 420.
Okay, I would put an arrow at the end of that line. Why would you put an arrow? Because you can keep working, right? She can work, she can babysit a bunch of hours. So I'd put an arrow at the end there. All right, domain. Okay, X is hours. So what's the least amount of hours that she'll work? 0. And where's that going to stop? Infinity. Right? She could just keep working and working and working. So go from 0 to infinity.
She can leave from become an infinity.
Okay, if she babysits for 20 hours, how much is she going to make? How are we going to figure that out? Yeah, so you just plug it into your equation. Y equals 7.5 times 20. Oops. That doesn't look very good. Can anybody else confirm 150?
I do.
Okay.
Perfect, that's all.
So she would make $150 if she babysat for 20 hours.
20 hours? That's a
long time.
whole day.
That's a long time.
I'm doing. I don't feel like you gotta take your ears together.
Okay, these are a lot like OST questions. What's the OST? Yes. Here, okay, so these are going to look a lot like, this is kind of like what you would be asked within this type of question here. So a shipping company charges a cost per pound plus a fixed fee. What is the fixed fee? Okay, we talk about fixed being one time. What happens one time? The y-intercept, okay? So the 575. So they're just seeing if you know what is constantly changing and what is fixed. That's all they're looking for right here. Emerson has $120. each week he saves an additional 15. Okay, so it says write a function. So I need you to tell me what happens once he has $120. What is constantly being added? 15. Okay, so it would be 15x plus 120. All right, I think the next page is practice. Yes?
Yeah.
All right, get your practice on. My grandpa.